Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Examine the continuity of the function h of x equals x ln x, right? So like in our previous videos, this problem is based on the algebra of continuous functions, right? And we're allowed to figure out and write down what is our f of x and what is our g of x. So let's do that first. So my f of x is x, right? And my g of x is ln of x, right? Now I know that my f of x is continuous at all x belongs to R, right? But is my g of x continuous it all belongs to R? That is what we will have to examine before we conclude h of x and its continuity, right? So let's write down first what is f of x continuity, right? So f of x continuous at all x belonging to R, right? And let's spend some time on g of x, right? Ln of x is the function g of x, right? So when I write it, let's call it by, say, y equals ln of x, right? And let's spend some time on this particular function. So what does it actually mean? X equals e to the power y, right? And what is this? This is nothing but the inverse of the function y equals ln of x, right? X equals e to the power y. So let me highlight this and I'm going to move to the next line and I'm going to discuss this particular function, inverse function, right? When you observe this, we know that e to the power y, e is a constant and y can be any number, right? It can be any number, be it positive or negative, but it has to belong to R, right? And as long as it belongs to R, which is the set of real numbers, we know that e to the power y is finite, right? But there is another close, uh, but there is another observation when it comes to e to the power y, right? We know that x is always positive, right? X can never be negative, right? Because e is constant and e to the power anything, be it a positive number or a negative number, which is your y in this case, never results in a negative number, right? So x is always positive. So that is point number one. Now, when x is always positive, what does it mean? It starts from zero, right? So that is what we mean by x equals, x is always positive. But when you look at this particular function, x equals e to the power y, when does x take a value 0, right? X takes a value 0 when y takes a value minus infinity, right? So which means, let me go to the next line and I'll probably write it. X can never take a value 0. And why is that? Because, let's move to the next line. Because when x equals 0, y takes a value minus infinity, right? And which is undefined, right? And therefore, x cannot take the value 0 for this function, right? Let me write it. right? So I'm gonna repeat this. So we know that x equals e to the power y whenever y equals ln of x, right? And x is always positive, right? Because x, what is x? X is e to the power y, right? And e being a positive number, y, let it belong to the set of any real number, right? Be it positive or negative. X is always positive. Now we are left with the question whether x can take the value 0, right? We know that x is positive, but can x take the value 0? Because when x takes the value 0, we see that y takes minus infinity, which means our g of x, what is our y? Y is nothing but g of x, right? So let me call that out here. G of x, uh, it becomes uh, minus infinity, which it is undefined, right? You're not, it is infinite, it is infinitely large, that you do not know what the value is. So then x also cannot take the value 0. So what is the value that x can really take here is what is we are left to answer before solving the final h of x problem, right? So let me retain this. And what do we have? Therefore, for g of x, right? G of x, we saw that is continuous in interval 0, and I'm doing an open bracket because it does not include 0, right? And again, a close bracket, infinity, which means g of x equals ln of x is continuous in the interval open bracket 0 to infinity, which means it does not include 0, does not include infinity, right? So so now we have what is required to answer our final question, right? So I have the continuity for f of x, and let me highlight it in green. I have the continuity for g of x, let me highlight it in green as well. And now if I go back and apply the algebra of continuous functions, I know that my x ln x, right? Therefore my x ln x, which is the answer for this question, therefore h of x, which is equal to f dot g, is continuous only in interval 0 to infinity, right? So I hope you found this problem useful. Please do subscribe to my channel and support. Thank you.